8452. You're closer. You're closer.
There's a decimal place sign this one.
Yeah. Yeah. So anyway, we'll practice these so you'll get better. And I'm going to turn this off. Where's my remote? And I'll drain the. Yeah.
Brennan, can you clean up my stuff for me?
Don't use tissue. It doesn't work.
Precipitated.
They want to make a
Already washed my
If you sweep up road dust, you can do the same thing and recover platinum. It's not worth it. Your reagent cost is way higher than the platinum value you can recover, but it's kind of neat knowing that you can do it.
And probably with people going away computers and all that, there's gold in that stuff.
Yep.
They'll be mining trash dumps before long.
So we were talking about that yesterday, getting gold out of old cell phones and electronics.
Oh, say hi. Hi, I'm flipping from one online class to another. Yeah. It is pre-cal now, right?
Yes.
Where are they?
Everyone's kind of running behind today.
I am.
Yeah.
So now I'm going to goodbye. And I wish I could get this back 30 minutes of sleep, you know. And then I realized I was looking at the clock thinking it said 5 something, but it actually said 6 something. And I'm supposed to get up at 6.
Time to go.
So I was like, wait.
It's made of plastic. I don't know. A lot of things are made of chives.
No.
Chives are made of chives.
Yeah, that's like the only thing.
Hey, you put a lot of stuff, chives and stuff. I put chives and
I
stuff.
just had such a hard time.
I don't even know what a chive is.
It's
Yeah, you have to. All your technique has to be perfect.
Nerd.
It's hard to get good results.
Yeah.
I like that in biology.
Yeah.
No.
It's more fun. than
No.
biology, but
They rusted. They erased their message board.
Yeah, because I'm supposed to do that. This is more concrete. Yeah.
Exactly.
Yeah. Then you gotta start getting into the quantum stuff.
Yeah. It's funny. When I interviewed at the lab, one of the things I told him is,
Oh.
yeah, I actually hate my history.
September, guys,
I did the
But I didn't know why.
It's August 32nd.
Yeah.
It's August. It's August 30th. August 30th. Yes. It's August
I don't
30th.
believe it.
I hate it too.
Yeah.
Technically, if you just want to say August, yes.
2020 is gonna go 11:59, 59 seconds to 11:60,
Oh, yeah.
and then we're gonna go to 11:61. It's just gonna continue on. You know, it's like
And the partners were writing out some derivation on the board, and you just kind of turn.
I don't know why, but I'm
That's where
putting all my
chemistry comes
all the
from.
time.
2020 is
Because,
another
you know, chemistry is really just
2020.
I'm a licensed vet.
Yeah,
I got my rabies vaccine this year.
You have a rabies vaccine this year?
That's why we teach physics first, or we were doing that.
The whole time.
Now we're doing tech.
You got a rabies vaccine?
STEM.
This one?
I like to go to my pet.
Let me see, do I need to let somebody
Oh,
in?
you probably should.
I lost my pencil.
No, rabies vaccines, like,
Oh, she's not there
you don't
yet.
want to have to get a rabies vaccine.
I know.
Let me see what I did
It's
before.
not just one shot, it's a series of
I know.
shots in very painful locations. Not a pleasant experience. Yep.
Shots.
Speaking from experience.
Veterinarians will get rabies booster shots because they're dealing with animals. Animal control workers will get booster shots. Not a very pleasant experience.
The stomach. Yeah, not comfortable at all. Oh, there she is.
Which is certain death.
Have y'all read Old Yeller?
Yeah.
Well,
That's what Old Yeller got.
There's only one known person in history that has survived rabies without being vaccinated.
Really?
Yep. It was a few years ago.
Hey,
I feel like I heard.
let
about
me change our,
And
I'm gonna 10.
read it on her own.
There we go. And,
It's the rabies testing.
okay, let's see what we're doing here.
Rabies.
Catching up on ourselves. Okay, turning around. Ah, okay. You got your planner? Oh, I gotta display something on the board. I already did it. Oh, okay, no, on your whiteboard, get your large whiteboard out. Share screen. I gotta go to. Password.
I don't remember.
Okay, so see if you can sketch these guys from memory. And like I said, I couldn't make x squared, so I just spelled it out. See how many of them you can do it. Whoever gets the most accurately, I'll give Smarties to. Okay, so far so good, but don't anybody see.
Hold on. So once I've shown it to you, do you erase it?
Now you can put them all on one whiteboard because they're just little. You can put 1, 2, 3, 4, 5, 6. You can probably fit 7. And if you need another big whiteboard, you can get one out of another desk. There's y equals x, y equals x cubed, y equals absolute value, square root of x. And then this means greatest integer function. Remember greatest integer function? We all went through it unless it was COVIDized. And then 1 over x. We can name them 1, 2, 3
Yes.
if you want. I
First
wish I
one,
could
for
write.
that reason it wasn't correct, because you had yours
I tried to fix it.
correct. You went too
That's
far.
what I was thinking. I was like, dude, I don't think
Right
this is
there.
right.
You can plot a couple points if you want.
It's easier if you start from that and then just make 2 curves going down like that.
Oh. So pretty much you just start from 3 times.
No,
It was a little wonky.
you were like, like 6 square lines, 3 in the first one.
What was supposed to be X squared, but yeah, then it was like, no, wait, that's.
Anybody got 4 of them that they're pretty sure about?
I have. I don't know.
What's the double absolute value?
What?
I don't know.
Greatest integer function.
Okay, that's right, but it's not right.
Is this right?
Where is he?
Isn't that the double square? It's double.
No. Greatest integer value. I got 3.
I'm really just
Yeah,
guessing
look
at
at
this
this
value.
Okay. All righty, I don't think anybody gets a Smartie today. Good, yeah. 4.
I was guessing on that
Yeah. Okay, I'm gonna put them up here. Let me move this around so she can see. Can't write on her screen. Hang on. Uh-oh, this is gonna be tricky. Nope, I got it. Okay. Y equals x squared. Most of y'all pretty good at that. It is a parabola with the vertex at the origin.
Wait. Oh, I got this wrong.
You got it wrong? There, that's right. Y equals x is a line going straight through here. Because you have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 on it. -1, -1, -2, -2. Yeah, because y equals x. Y cubed. I was surprised that many of y'all got this one. It kind of goes up like this, goes through the origin and like that. So it's kind of like y equals x, but it's got a little squiggle in the middle. Okay. In fact, if you zoom out, it looks almost the same as y equals x, but with a squiggle in the middle. And then absolute value, y'all were pretty good at. The V shape, which is basically y equals x, where this bottom part has been bent up into the other quadrant. Then square root of x. If it was the plus and minus square root, it would look like a parabola going sideways, but then that wouldn't be a function. But if it's just a positive square root of x, it's like a parabola, but only half of it is like sideways. Okay. Okay, this one right here is a step function. Do you remember that? Where you had kind of like a, let me go up here and go up here. And, remember that? Remember seeing pictures of it? And it was the same down here. And I could be having my open circles and closed circles backwards. They are backwards. How do you remember?
I do.
Oh. Dang it. Okay. Well, Google's always smarter than me. And then 1 over x is, remember, it's a 2-part. It has this on this side, and it goes up toward the axes and down over toward the axes, and then over here in this one. And you don't have anything on the y-axis because what's 1 over 0? Undefined. And so it's just scared to cross the y-axis because that breaks everything. Okay? So anyway, if you open your textbook, just the first front cover of your book, what do you think you'll see?
Wow. So many graphs.
Graphs.
Oh, gosh.
Yeah, kind of look just right there, right? And I haven't taken roll. Need to get you on my class list so you could take roll for me. Okay, let's see here. Because I have these openers and I always get so excited and interested in it that I forget that that's when I'm supposed to be doing this. And then go to Precal, attendance, and then go to present and grade, and then back to the whiteboard, which is right here. No, that's not it. Dang it. Where is the whiteboard? Here? Somebody help. Down here. Is that one? I'm just totally lost now. Okay. My screen sharing is paused. Oh, what happens if I click on that?
And
Okay.
I think you can share screen and then choose the whiteboard.
Yeah. Okay, but let me go ahead and share screen because I don't. And then that was the question. Ah. Where is it? Oh, because I went to a different. Okay. I remember where I was. That was, okay, X that out. This shop. Okay, because I closed it. Try this again. Sorry, Candace, I'm just having a hard time here. WebEx Teams, I don't want that one. Amazon Music, tempting. This one. Let's try that one. And okay, move this down. Ah, whoa! I got back.
Yeah.
Okay. Ronnie, never take roll like that. Okay, now what I want you to do And you can notice this, they have this listed on the front cover. I can't see all mine from the front cover. Is they talk about different characteristics of these different graphs. So the first one they have is y equal x. I think, yeah. And so let's look at this right here. What is the domain of y equal x? How far to the right and to the left does it go? Infinity and beyond, right? And so what's the domain?
All real numbers.
You can say negative infinity to positive infinity, or you can say all real numbers, either way. How about the range?
All real numbers.
Because it goes forever up and forever down. So it's all real numbers on the y-axis. What about increasing, decreasing, constant?
Increasing.
It's always increasing, right? Yeah. What about the y-intercept?
0.
At the origin, all right? What else? Does it have maximum or minimum?
No.
No, it doesn't have any maximum or minimum because it just goes up forever, okay? So that's just different ways you can talk about that. If we had to have it fill out some kind of survey or form about itself, these are all the things it would have to fill out, right? What about y equals x squared? What's the domain? Does it go to the right and to the left forever? Yes, it does. So its domain is all real numbers. What about the range? Yeah, it goes up forever, but it doesn't go down forever. It doesn't get any lower than 0. So the range is y greater than or equal to 0. So you'd have to say like that. But you have to include 0, right? Or you could do the parentheses and say, no, you do a bracket, 0, comma, infinity, parentheses. That's the interval notation. The bracket there includes a 0, where the parentheses would not include it. Okay, what about increasing and decreasing?
Decreasing from infinity for negative infinity to 0.
I think it's decreasing from negative infinity to x equals 0.
And then increasing from 0 to
And then increasing from 0 to positive infinity. Does that make sense? What about the y-intercept?
0.
Yeah, origin. X-intercept? Origin, right? What else do you say about it? They show that on the bottom of them, in the middle. Intercept, range, domain, increasing, decreasing. Oh, is it odd or even? This one, even, because it's symmetrical about the y-axis. What about y equals x? It's odd because it has symmetry with respect to the origin. Okay, so odd or even is important. And then they also ask about symmetry. But that's kind of weird because it seems like if you say odd or even, then you already stated the symmetry. Let's do another one. How about x cubed? What's its range and domain? They're both what? All real numbers. X-intercept is the origin. It's always increasing. Okay, always increasing. Odd or even? Odd. Could you? And that the cube helps you know that because 3 is an odd number, but also has symmetry with respect to the origin. What about the absolute value? What's its domain and range? Its domain is all real numbers. Yeah, same as the parabola, 0 and up for the range. What about, I mean, everything's very similar to this, right? It's just that this one's curved and this one's not. I wonder if it has anything different about it. On the pages, decreasing and increasing. It's an even function, y-axis symmetry. Both of them have minima. There's a minimum here at the origin and a minimum there. That one doesn't have a minimum. Okay, then we could get into this thing. Oh. Let's think about this. If this keeps going like that and keeps going like that, what is its domain? All real numbers. The range is tricky though. You think, well, it keeps going up and keeps going down, so it should be all real numbers, but
They're a little stupid.
It's not, because it's only doing the integers. We're only using these dots on the y-axis. We're not using all the dots in between, only those dots. So the range, you would say the integers is the range. Okay, does that make sense? Yeah, you don't have anything in between in here. Then I do have it different. They have it on the bottom of page of your binder there. They say it's for the increasing and decreasing. Well, it's always it's constant. How do they say it? Constant between each pair of consecutive integers. And it doesn't even say that overall it's increasing, because at no point is the graph actually increasing. It's constant here, and then it jumps, but you don't have any part of it that's increasing. Weird, huh? Oh, probably because she's has questions or something. I don't know. What is this? Chat, yes. Okay. Hang on, Candace, I'll be with you. I'm gonna stop sharing. Can't hear. The screen froze. What was that about step functions range? Oh, sorry about that. Can you hear me now? I got too far away. Okay, so the step function, the range is only the integers, because it's only, like if you were to, hang on, I'm going to go back to sharing the screen because I think you can see it better that way. That's the, where am I? Am I on the whiteboard? No, I'm still on. I'll stay there. Okay. Yeah, okay. So if, say you were to collapse all of these little things, push them all so that they were all sticking to the y-axis. Can you imagine that? Like push this one over here and keep that one there, and then push this one over and push this one over and push this one over. They would all be just touching it, only where the integers are, only at 1, at 2, at 3, at 4. Yeah. So the range, the only y values that are being used is just the integers. So you would say r equals, and you could put z, because, and you would kind of double, that means integers, or you could just write out the integers. Okay, so I'm gonna unshare and let's go. I might turn it off completely. Yeah, I'm going to. Okay. Option. And thank you. Good, good. Okay. So you can see, I'm going to get the remote. It's hard for me to keep all these different things in my head. Dang you, COVID. So my 8-year-old grandson always says, he wears a little gaiter around his neck, and sometimes he'll forget it and be, COVID. He has to go and wear a regular one, he says. Okay, so turn to section 1.6, which is page 60. That's not gonna go around it. Yeah, it will, yeah, it will. Okay. Turning it. Swivel robots are supposed to come in soon. You know what those are? That'll help some of this stuff. Maybe. I don't know. It's just one more thing they'll have to learn. But anyway. So the library of parent functions. So all these functions in the front cover, you have them in the back cover too. Some of the books did. No, you got what I got. Look back at your book. You have 2 pages. 1, 2, 3 pages of functions. Yeah, what, 3 pages? Right. And eventually I'm gonna make a copy and have these for you to have in your binder so you can take them out when you take a test or something like that. But I want you to notice that for each function, these are all parent functions, right? And how do you go from a parent function to some other function? There's a word that we use. Yeah, you all right? You almost said, you said translate.
Transition.
Transition, not transition. Not yeah, transform. I was thinking translation, but it's transformations. The transformations are where when you can stretch them out, make them skinny, move them around, but you're always starting with a parent function. So all parabolas, no matter how skinny or fat or where they are, they're daughter functions of the parent function y equals x squared. Okay? And it's important to know what each parent function is, what it's called, and what its characteristics are. Its domain and range, its intervals of increasing and decreasing, the maxima and minima, symmetries, things like that. Okay, and so you have those in the front of your book. Like I said, I'll try to make copies of them for you. But for the end of this course, we will have gone through all of them. Okay, that's the main purpose of this course, is to learn all these types of functions. So if you learn the basic parent functions and then you know how to do transformations, then that's all the functions. Well, all the main functions. There are a lot of weird ones that we won't go into until calculus. Okay, when they really start misbehaving. So back to 1.6, page 70. Most of this starts out pretty easy because it's a review of functions you've already messed with a lot. On page 60, it talks about linear, and then it jumps over to squaring functions. So a linear function is y equals x, or mx plus b if you transform it. And the squaring function is just y equals x squared. Okay, and look at the top of page 61. There are 2 special types of linear functions, the constant function and the identity function. Okay, so the constant function is just when you have y equals some number. And so what does that look like on a graph? Just a big flat line, right? Whatever that number is. So if it's -5, it'd be down here where -5 is, right? And then the identity, this is constant. What's its slope? 0, right? And then the identity is what we were talking about a minute ago, y equals x. If y is x, it's like they have the same identity, right? And it's that one like that. And if you write it in y equals mx plus b form, it's 1x plus 0, right? And if you start changing the numbers here and here, you can move it, tilt it any way you want to. Okay. But what about a vertical line? How come they didn't talk about a vertical line? Like x equals a constant. Why are we discriminating? Yes?
It's not a function.
It's not a function, remember that? How many times would a vertical line, how many points would it hit? All of them, like all infinity, yeah. So it's not a function, but it is a relation or a line that you have to know about. And then they mention the squaring function on page 61. And see all the bullets above that? How many bullets is that? 7 bullets? And those are the same characteristics that they show in the front cover about describing it. Whether it's increasing, decreasing, domain, range, maxima, minima, all that stuff. Okay, now turn the page. We're moving along pretty fast. Page 62. The cubic, what's that mean? Y equals what? X cubed. Okay, and you see what it looks like there. And we already talked about a lot of this, how it's, what its range and domain is, and how it's odd and has an intercept at the origin, and it's always increasing and so on. Then look at the square root function. Can you imagine if there was a reflection of it over the x-axis, how that would be a parabola? We're not even on, right? Oh no, you got one of those books. No, you're right. I'm sorry. In my book, it's on the left. Not in your book. It's on the right. So right there, yeah. Okay. So yeah, so you're just closest. So you got a parabola sideways, and we only do the top part. But if you did have a negative in front, remember putting a negative in front of an equation flips it over the x-axis. Right? Putting a negative in front of the x itself flips it over the y-axis. We'll go back and talk about all these transformations soon. And then you got the reciprocal function, y equals 1 over x. It's called the reciprocal function because 1 over x is the reciprocal of x. And that is weird because you got two parts, two branches, but it's all one function. And it has horizontal asymptote. Remember what asymptote is? Y'all talk about that? The graph gets closer and closer, forever getting closer, but never touching. Weird, right? And not only does it have a vertical asymptote, which is the y-axis, but it has a horizontal asymptote, which is the x-axis. Okay. The only interesting stuff on it is right there at the origin. And look how they do the domain. I'm going to come over here closer, and I'm going to get a better marker. I don't know which families buy these. The generic never worked that good, right? Okay, so let's see. So you got this going, right? And it's easy. Sometimes when you draw it, you want to like make these lines get further, but you always got to make it where it looks like it's getting closer and closer, but never touching. And look what it says for the domain. It says parentheses, negative infinity, comma, 0. And then there's this weird looking U, and then another parentheses, 0, comma, infinity. And that's the domain. What?
Is the U like and or?
It's one of those. It's a or, okay? And by or, it means a combination of the two. So we would say this and that, but it's not and. It means or. Like if somebody said, stuck their head in the door and said, I need either a junior or a girl to come out here. Then that would include any of you, right? Because all of you are either a junior or a girl. So that would include both groups. So in that case, or just means all of this and all of this. But see what it's leaving out? It's not putting a bracket here, so it's not including 0 here or here because it's a parentheses, not a bracket. So you have from negative infinity up to 0, but not 0, and then just past 0 to positive infinity. It's easier just to say x is not equal to 0, and that's my domain. But you got to learn all these kinds of notation. And the range works the same way. It's odd, does not have any intercepts. Okay, then we get over to on page 63, the step and piecewise defined functions. Now, could your calculator graph that, do you think? Let's get it out and try. Let me find mine. I'll be talking about an 84. If you have an Inspire, you're on your own momentarily. Okay.
Sorry, which one are you
The step function, and I know it's in here somewhere. Okay, so let me clear. Math. Okay, go to math. Go over to num. Okay, and go down to number 5, int. Okay, so these are the buttons you push. Math. And then you go over to where it says num, as in number. And then you go down to 5, and it says int. Right, int. It has a parentheses there. Okay, now remember how you did that. Go to y equals, and then do all of this again. Y equals, make sure it's clear, so you're at your y1 equals, and then do your math over to num, down to int, and hit enter, and mine actually has this on the screen. Does y'all's? And y equals? Because some of the fancy ones, okay, yours, I think you're gonna have to go to your catalog, which is a little book.
Click the book, then select number 3.
And then click on what?
3. Middle.
See if you did that. Oh. Three. This is like the right.
Yes.
Let me see.
I clicked this, but
Yeah, you haven't found it yet.
I don't know what it looks like.
I think if you go go down to the ends. No, I. G raised to the third. Maybe just integer I. I think if you do.
Just the inner.
Look for integer.
Or if we double the square bracket.
Okay. So now just type in X and close your parentheses. Type in X, close the parentheses, and then hit graph. Yeah, integer.
Where you find it?
INT, yeah, INT parentheses.
Where is it? Where?
It's in the, if you go to the book, but don't go over any. No, let's see where, this little book here.
This is what.
Okay, then go down. But you're gonna go up. If you are the T's and the D's, go up. Okay, so whenever you want to graph a greatest integer function, you'll use that thing in your calculator. Candace, did you find it on the calculator? Good. Now, how do we know for sure when it's doing that? Let me down closer so she can see. There you go, up. So if I do a vertical line this way, it only hits in one point, right? And if I hit it, if I go like this, where it hits on there and then there, that's still only hitting one point?
Yes.
Yeah, it's only the one that's circled in that it's hitting. So, and right before that, it would be on here, and right after that, it would be on this one, okay? So the Y value would be, so here's your 1, 2, 3, 4. So maybe this is 1, 2, 3. So for all these X's, your Y value is 3. And then as soon as you get to right here, it jumps up to 4. And it'll stay 4, 4, 4, 4, 4, 4, and then it'll finally jump up like that. So it never does decimals. It'll just stay on the integers. And it says that when you're using your graphing utility to graph a step function, you should set your graphing utility on dot mode. Let's see what that does. The way you do that is you do second zoom, which is format, second zoom, and somewhere where it says grid on, I think that's the same thing as the dots. The turn grid, maybe not, I'm not sure, let's see.
Like this.
Yeah. I got dots. Yeah, I don't know why. I guess that helps you see which dots they're going to. Which is more clearly. And I don't like it. If I go to zoom and hit square, zoom square, it looks a little better to me. The resolution of these screens isn't so good. And so it looks like there's like gaps between rows of dots. But with the newer calculators, it looks probably a lot better. Yeah, so you see kind of like the lines where there are gaps, that's just the resolution of the screen. If you guys put monkey around and find it, you can get a better picture of it.
Mine's
Here's the mirror on that one. Yeah, you don't have the same weird looking effect. Yeah. Anyway, calculator is a hidden treasure trove of fantastic things. Okay, let's look at a problem. We've kind of been, see you later. Oh, what time do we get out at? 12, yeah. I haven't been having, I'll come up to the board because these are like, I haven't really been having too many checkpoints, but there is a checkpoint on page 63. So let me do an example like that. Because these step functions are just weird to deal with. Kind of like, I wouldn't say like stepchildren. I don't know if any of y'all are stepchildren. So I am not, and I don't have any, so I can everything talk about it. Okay. I have some step nieces and nephews that are so adorable. They're so cute. Okay, it says evaluating a step function. And they give an example, the equation f of x equals, and then they have those two lines. That means step function. The two lines like that. And they put little brackets, or two brackets, I guess. It's kind of like two brackets. And then they have +1. And they say evaluate that when x equals -1, 2, and 3/2. Okay, and so if I was to evaluate it at -1, I would say, I put a -1 in here. So what does this mean when I have a -1 in there? It says it's going to equal the greatest integer less than or equal to this number. Well, this number is an integer, right? So the greatest integer less than or equal to it is -1. And so that goes to just -1. And then I would say +1, and that would give me 0. Does that make sense? Okay. Now they say, what about 2? Let's plug in 2 here. Well, again, as long as you're plugging in an integer, it's going to evaluate as that integer. In other words, this sign with a 2 in it just means 2. And then 2 + 1 is 3. So f of x would be, the y value would be 3. And all you're really doing is you're shifting the whole original thing up 1, right? Transformation. What happens when we put 3/2 though? 3/2. What is the greatest integer less than or equal to 3/2?
1.
1. How come? It's because 3/2 is like 1.5, right? And so the integers on either side of it are 1 and 2. The 2 is bigger than this, than 3/2. So the greatest integer less than it is 1. And so your answer would be 2 for the y value. Okay. If you can put it in your calculator, then you can have the calculator do all the evaluation and just go to your data table. Okay, like if I put this into my calculator and then I set my table set to start at 0 and go by 0.5, it would tell me what 1 and 1.5 and 2 and 2.5 is, and it would show me what the actual values are. Okay, so y'all want to try one? Go to the board. Take your own little marker. F of x equals greatest integer sign, and inside it is x + 2. So you got the double brackets on the outside of x + 2. Yeah. So now we're going to evaluate it when x is -3/2, 1, and -5/2. So evaluate it for all three of those. So remember, PEMDAS means you do what's in the parentheses, or in this case, brackets, first. Oh my goodness. Quick. Plus 4 2s. I'm getting a common denominator to add them. 4 minus 3 is 1. And the integer less than or equal to 1/2 is 0. Okay, good. So that's what f of negative 3/2 is. We'll do that. F of, what's the other one? I'm going to jump over to negative 5/2 and do it real quick. We'll get negative 1/2 in there. Now, which digit is less than or equal to negative 1/2? Negative 1. Zero is bigger. I think 0 is bigger. So it's,
Totally.
yeah, I know. When you get to the negative numbers, I always try to picture it and think which one is to the right. That's bigger. That's the wrong one. Which one is to the left? Always think about which one is to the left, and that'll help you. Okay, I'm going to pass out the success organizer for homework. Let me see if I'm just going to pass out. I know, right? But we didn't talk about the piecewise defined functions on page 64, so you don't have to do that part yet.
Is this homework?
Yeah, just do as much of it as you can for homework, and then we'll finish it in class tomorrow. I just don't want to start from the very beginning. Did you get these to the other girls? I may have given her one, so I'll probably have one left over. You.
I used my pencil right out of line.
Can I borrow somebody's pen or pencil? That room, it's not good for the markers either. Oh, homework. Okay, good job. See y'all later. Have a good lunch.
Here you go.
What?
Yes.
You give it to me like that?
What? Kylie, is that what you listen to?
So Candace,
Not usually, but.
when you're doing that greatest integer thing,
It's really good.
if you had
So it's just gonna be one song over and over.
something like this.
Wait, what are you listening to? That's good.
I listened to a sea shanty.
If you think about where that is on the-
That's really good. So I will listen to it.
Is it an Irish one?
No.
It's right here
See,
on
what?
the number line. And so instead of what you would write for this would be whatever integer is just to the left of it. It's always the integer to the left of it. So for any number in here, the answer would be 0. If you had anything inside here between 0 and 1, the y value is going to be 0. And then if you had anything like, say you had 3/2, that's right here, then your answer would be 1.
My knee hurts.
Whatever your input is, the output is the digit, is the integer just to the left of it. Does that make sense? I know it's confusing.
No, I'm saying that you kept cutting out a bit.
Oh,
What was
I-
that about? Input?
Whatever the input number is that's inside those brackets, okay? The output number is whatever integer on the number line comes just before it.
All right.
So like if it
Thank
was,
you.
yeah, if you had like a 6.19, well, it's Greatest integer would just be 6. It's kind of like you just wiping off the decimal part and to keep whatever is in the ones place. And we'll talk a bit more about page 64 tomorrow, and then we'll have time to work on the organizer handout and start working on the questions in the book.
Yes, ma'am.
Alrighty? Okay, I'll talk to you later then.
Did you send me the section 1.5? Or is it in one of the previous links?
It's on the success organizer links. You already did 1.5.
Oh, excuse me.
Yeah, this is 1.6, and I put it in that folder. There's a link to it.
Thank you.
Okay, and to the PowerPoint if you're interested in looking at the PowerPoint.
Yes, ma'am. Thank you.
See you later.
Bye.